All right, so what you do here to calculate the age of this sample right here is you have to know the number of radioactive isotopes. So the radioactive ones are the yellow ones, and the number of the total atoms in here. So in this case, there is 20 total atoms in this sample, and 17 of them are radioactive. So I get my calculator and I type in 17 out of 20 are radioactive. That gives me 0.85, which we all hopefully should know is 85%. So 85% of the sample is radioactive. I know because it says it's carbon that I'm going to be using the carbon graph. So I make sure, yep, it says it's carbon, and I go to 85% right there and then follow it down. So I know that it's going to be a time before 5,700 years. And if I look at this table, it gives me 90% and 80. I know it's got to be somewhere in between. So any number, any estimate somewhere in between these two numbers would be considered correct. So this is probably pretty close to about 1,200. And that's how you would solve the first one. So this is sample number 1. It says so right there as well. You have 8 of these samples to do. Here is the handout I gave everyone. This has the main radioactive half-lives data on it, which is really helpful for calculating this. This is the first sample that we just did together, and then the second, and they go on in order from there. Hopefully you can tell the number of radioactive isotopes in there. Each container either has 10 or 20. So if you pause the video and look back, hopefully you can figure out or estimate how many there are so that you don't have to come in and do this in the classroom. But if you do, I am here and I am totally willing to help you. The handout that has the graphs and stuff, it is also placed in the folder for the student notes.